Host-based intrusion detection. Under host-based intrusion detection, we are going to see about what is intruders, what is intrusion detection, host-based intrusion detection, data sources and sensors, anomaly heights, signature or heuristic heights, distributed heights, architecture for distributed intrusion detection, and agent architecture. What is intruders? Intruders are the hackers who attempt to breach the security of a network. They attack the network in order to get unauthorized access. One of the key threats to security is the use of some form of hacking by an intruders. The various classes of intruders are cyber criminals, activists, state-sponsored organizations, others. Cyber criminals. They are either individuals or members of an organized crime group with a goal of financial reward. Next is activists. Activists are also known as hacktivists. They are either individuals, usually working as insiders, or members of a large group of outsider attackers who are motivated by social or political causes. The next is state-sponsored organizations. They are groups of hackers sponsored by governments to conduct sabotage activities. Others are hackers with motivations other than those listed above, including classic hackers or crackers who are motivated by technical challenge. Across these classes of intruders, there is also a range of skill levels seen. These can be broadly classified as apprentice, journeyman, and master. Apprentices are hackers with minimal technical skill who primarily use existing attack toolkits. Journeymen are hackers with sufficient technical skills to modify and extend attack toolkits to use newly discovered or purchased vulnerabilities or to focus on different target groups. The next is master. They are hackers with high level technical skills capable of discovering brand new categories of vulnerabilities or writing new powerful attack toolkits. Some of the examples of intrusion: performing a remote root compromise of an email server, defacing a web server, copying a database containing credit card numbers, etc. Next is, what is intrusion detection? Intrusion detection, a security service that monitors and analyzes system events for the purpose of finding and providing real-time or near real-time warning of attempts to access system resources in an unauthorized manner. Security intrusion. Security intrusion means a security event or a combination of multiple security events that constitutes a security incident in which an intruder gains or attempts to gain access to the system without having authorization to do so. The intrusion detection system comprises of three logical components: sensors, analyzers, and user interface. First is sensor. Sensors are responsible for collecting data. The input for the sensor may be any part of the system that could contain evidence of an intrusion. Types of input to a sensor includes network packets, log files, system call traces, etc. Next is analyzers. The analyzers receive input from one or more sensors or from other analyzers. The analyzer is responsible for determining if an intrusion has occurred or not. Next is user interface. The user interface to an IDS enables user to view output from the system or control the behavior of the system. In some systems, the user interface may equate a manager, director, or console component. These intrusion detection systems are classified based on the source and type of data analyzed as host-based IDS, network-based IDS, distributed or hybrid IDS. Host-based IDS monitors the characteristics of a single host and the events occurring within the host, such as process identifiers and the system calls they make for evidence of suspicious activity. The next is network-based IDS. Monitors network traffic for particular network segments or devices and analyzes networks, transport and application protocols to identify suspicious activity. Distributed or hybrid IDS. This combines information from the number of sensors, often both host and network based, in a centralized analyzer that is able to better identify and respond to intrusion activity. Host-based intrusion detections. Host-based intrusion detection add a specialized layer of security software to vulnerable or sensitive systems such as database servers and administrative systems. It monitors the activity on a system to detect suspicious behavior. The benefit of HIDES is to detect both external and internal intrusions, something that is not possible either with network-based IDS or firewalls. Data sources and sensors. Common data sources includes system call traces, audit records, file integrity checksums, registry access. System call traces. A record of the sequence of system calls by processes on a system is widely acknowledged as the preferred data source for HIDES since the pioneering work of Forrest, while these work well on Unix and Linux systems. Next is audit records or log files. Most modern operating system includes accounting software that collect information on user activity. The advantages of using this information is that no additional collection of software is needed. File integrity checksum. A common approach to detect intruder activity on a system is to periodically scan critical files for changes from the desired baseline by comparing a current cryptographic checksum for these files with a record of known good values. The disadvantages include the need to generate and protect the checksum using known good files and the difficulty monitoring changing files. Registry access, an approach used on Windows system to monitor access to the registry given the amount of information and access to it used by programs on these systems. However, this source is very Windows specific and has recorded limited success. Next is anomaly hides. Anomaly detection involves collection of data relating to the behavior of a legitimate user over a period of time. The majority of work on anomaly based heights has been done on Unix and Linux systems. The system called traces are then analyzed by a suitable decision engine. Next, the time delay embedding algorithm based on artificial immune system approaches that compares observed sequence of system calls with sequences from the training phase to obtain a mismatch ratio that determines whether the sequence is normal or not. Later work has used other alternatives such as hidden Markov models, artificial neural networks, support vector machines, extreme learning machines to make this classification. Windows systems have traditionally not used anomaly based heights as the wide usage of dynamic link libraries as an intermediary between the request for operating system functions and the system call interface. The adoption of this approach should lead to the development of more effective Windows sites capable of detecting zero-day attacks, unlike the current generation of signature and heuristic Windows sites. Signature or heuristic heights. The alternative of signature or heuristic based heights is widely used, particularly as seen in antivirus, more correctly viewed as anti-malware products. These are very commonly used on Windows systems and also incorporated into mail and web application proxies on firewalls and in network-based IDs. They use either a database of file signatures, which are patterns of data found in known malicious software, or heuristic rules that characterize known malicious behavior. These products are quite efficient at detecting known malware. Next is distributed heights. Traditionally work on heights focus on single system standalone operation. The typical organization, however, needs to define a distributed collection of hosts supported by a LAN or Internet network. Although it is possible to mount a defense by using standalone IDs on each host, a more effective defense can be achieved by coordination and cooperation among IDs across the network. The major issues are distributed IDs may need to deal with different sensor for data formats. In heterogeneous environment, different systems may use different sensors and approaches to gathering data for intrusion detection use. So here the different sensors provide different data format. One or more nodes in the network will serve as collection and analytical points. Thus, either raw sensor data or summary data must be transmitted across the network. Therefore, there is a requirement to assure the integrity and confidentiality of this data. Either a centralized or decentralized architecture can be used. With a centralized architecture, there is a single central point of collection and analysis of all sensor data. With the decentralized architecture, there is more than one analysis center, but these must coordinate their activities and exchange information. The good example of distributed ideas is one developed at the University of California. The main components of this system is host agent module, LAN monitor agent module, center manager module. The architecture is shown here. It is the agent architecture. This architecture is general and flexible. It offers the foundation for machine-independent approach that can expand from standalone intrusion detection to the system that is able to correlate activity from number of sites and networks to detect suspicious activity that would otherwise remain undetected.